In this session of communication system, we are going to discuss about the height of antenna. In order to transmit the signal, we need the antenna of correct height. The height of transmitting antenna depends upon the wavelength of the radio signal which will be transmitted. If the wavelength of the radio signal is lambda, then the minimum size of the minimum height of the transmitting antenna must be 1/4 of the wavelength of the radio signal which will be transmitted. Hence, to calculate the height of antenna, first of all we have to know the value of the wavelength of the radio signal which will be transmitted. Now I am going to find the height of antenna which can transmit the radio signal of frequency 870 kHz. The frequency of 870 kHz of radio waves are used in AM broadcast. To find the height of antenna, first of all we have to find the wavelength of this radio signal of frequency 870 kHz. To find the wavelength, we have to use the concept of velocity of wave equals to the product of wavelength and frequency of the wave, right? C equals to f lambda. C is the velocity of the radio wave which will be 3 into 10 raised to the power 8 meter per second. The radio wave is one of the electromagnetic wave and it has the same velocity as the light wave, and hence the velocity of radio wave will be 3 into 10 raised to the power 8 meter per second. The frequency is 870 kHz which will be equal to 870 into 10 raised to the power 3 Hz, and from this we can calculate the wavelength of this radio signal, right? Put the value of C and put the value of frequency of the radio signal, we can get the value of lambda which will be equal to this one. After very simple calculation, we can get the value of lambda which will come out 345 meter. The height of the antenna will be 345 meter to 1/4 of this value, right? The wavelength of this radio signal equals to 345 meter, that you can see. Hence the height of this antenna will be 345 meter. This height of antenna is really difficult to manage and it is costly to build. That's why in general we need the antenna of height 1/4 of this value. Wavelength of this radio signal is 345 meter and 1/4 of the wavelength will be 86.25 meter. That means this one is the 1/4 of the wavelength, right? Hence, to transmit the radio signal of frequency 870 kHz, we can build the antenna of height 86.25 meter. Now take some another example. If the radio signal of frequency 10 megahertz will be transmitted, then what will be the height of antenna? If the frequency of the radio signal will be 10 megahertz, then the frequency will come out 10 raised to the power 7 hertz. To transmit the radio signal of this frequency, we need the wavelength, and the wavelength of this radio signal will be given by lambda equal to C by f. The wavelength of this radio signal can be calculated using the concept of C by f. The value of C is 3 into 10 to the power 8 meter per second and the frequency f is 10 raised to the power 7 hertz, and hence the wavelength will come out 30 meter, right? That means the height of the antenna will be from 30 meter to 7.5 meter to transmit the radio signal of this frequency, right? And you can see that the height of the antenna is drastically reduced if the frequency of the radio signal is of the order of 10 megahertz.